Good morning, class. How are you? All right, so we're working with rational functions. We're trying to solve rational functions. There's a number of ways we can go about this, but oftentimes the easiest way to do it is to try to get the same denominator for all the expressions inside your equation. So if we take a look at this first one right up here, number 1. If we take a look, when we have 6x squared, we have 3x squared, and we have k, the least common multiple between 6x squared, 3x squared, and k is going to be 6x squared. So basically what we want is we want 6k squared is equal to something over 6k squared minus something over 6k squared. Okay, so how do we do that? All right, so the first one is fine because we have 1 over 6k squared. That's perfect. Now for the second one, we want to change this. We want to change this here, this 1 over 3k squared. We want to change this into a 6k squared on the bottom. So we're going to multiply it by 1. So what do I have to multiply it by? 1. I'm going to multiply it by 2 over 2 because 2 over 2 equals 1. And that's going to be times, this is going to be 1 all over 3k squared minus, now over here I have 1 over k. I'm going to have to multiply this by 1. I'm going to multiply it by 6k over 6k. And 6k divided by 6k, of course, equals 1. So on our next line down here, we have 1 all over 6k squared is equal to 2, because 2 times 1 is 2, and 2 times 3k squared is going to be 6k squared. And over here, 1 times 6k is 6k, and k times 6k is going to equal 6k squared. Now, once you have the same denominator, then it's real easy because we could just multiply both sides by 6k squared. And my 6k squared are going to cancel out. Now I'm left with 1 is equal to 2 minus 6k. I subtract 2 from both sides. I get negative 1 is equal to negative 6k. I divide both sides by negative 6, and I get k is equal to 1 over 6. And that is going to be my answer. All right, so let's do another one if we could. Let's try doing number 7 if we could. Let's try do 7 right over here if we can. All right, number 7. Now, number 7 is a little bit different. It's very similar in some ways, but for instance, we want the same denominator. So if we look at v squared minus 5v, if we look at these here, if we look at this one and this one, they already have v squared minus 5v. So we're going to leave them alone. And we're going to change this one over here into having the same denominator. So if I have 1 all over v, and I need to make it turn into v squared minus 5v, then I'm going to multiply this by 1. I'm going to multiply it by v minus 5 all over v minus 5. And if you take note, v minus 5 divided by v minus 5 does indeed equal 1. So we're just multiplying this by 1. All right, so now this is going to be plus 3v plus 12 all divided by v squared minus 5v. It's kind of hard to write on this. It's equal to 7v minus 56 all divided by v squared minus 5v. Now when I multiply this here, I get v times 1 is what? Just v, right? And negative 5 times 1 is minus 5. And down here, v times v is v squared, and negative 5 times v is minus 5v. Now you can see that we have the same denominator in all of our rational expressions here. V squared minus 5v is equal to 7v minus 56 all over v squared minus 5v. But now if we multiply both sides, if we multiplied both sides by v squared minus 5v, all my denominators are going to cancel out. So now I get v minus 5 plus 3v plus 12 is equal to 7v minus 56. So on this side, v plus 3v is going to give me 4v, and negative 5 plus 12 is going to give me a 7, is equal to 7v minus 56. Now if I subtract 4v and I subtract 4v, on this side I get 7 is equal to 3v minus 56. If I add 56 to both sides, I get 63 is equal to 3v. I divide both sides by 3, and we can see that our answer is v is equal to 21. Now, in both cases, you always want to make sure you plug back in your answer to make sure that you don't have any extraneous roots. But we can see up here in this first one up here, if we look in this one, I'm not sure why that's not erasing, but that's all right. If we look at number 1, the only value for k that could possibly give me 0 in a denominator would be 0. And of course, we did not get 0, so we're okay. So what I'm saying to you is we're checking for extraneous roots. Over here, for v squared minus 5v, well, v squared minus 5v, to check for extraneous roots, we want to know when that equals 0. We can factor out a v. It's v times v minus 5 equals 0. So v cannot equal 0, and it cannot equal 5, because otherwise we're going to have 0 in the denominator. But we didn't get that. We got v is equal to 21, so we know our answer is correct. All right, class, hopefully this helps you. And if you have any further questions, please reach out to me. Thank you very much and have a wonderful day. I hope all of you and your families are doing well.